Okay, so in this lesson of properties of logarithms, we're going to look at part 3. And in part 3, we're interested in condensing log expressions. So remember in part 1 and 2, we expanded the log expressions. So we went from a log of a product to the sum of two logs. We went from the log of a quotient to the difference of two logs. And we wrote the log of a m to the power, so whenever you had an exponent, we wrote it as a product. And so we used the product rule, quotient rule, and then the power rule. Basically what's happening when we condense is we're going from this form to a single logarithm. All right, so when we condense, we're going from a sum, a difference, a product right here, to a single logarithm. And notice when we go to that single logarithm, we want the coefficient of the log right here to be 1. All right, so let me say that again. So to condense a logarithm, to condense a log expression means to write the sum or difference of two or more logs. So that could be 3, there could be 4 altogether, as a single logarithm. So you're going from this state to a single logarithm. You just got to remember that when you have the sum of two logs, you can write it as a log of a product. When you have the difference of two logs, you can write it as a quotient. And then when you have a log times a number other than, or something other than 1, you can write it as an exponent. Okay? It's not that difficult. It's fairly easy to deal with. You just have to remember these properties. You have to remember product rule, quotient rule, power rule. So instead of expanding, you're doing the opposite. You're condensing. Condense means to write as a single logarithm. Condense means to write as a single logarithm. Okay? All right, so it's not very difficult. It's fairly simple to deal with. So let's look at number 1. All right, so number 1, the direction says condense each log expression. Remember, condense means to write as a single logarithm. Just remember, though, you want to make sure that the coefficient of the log is 1. And then just as before, just like with parts 1 and part 2, where possible, evaluate the log expressions without using a calculator. Okay? All right, so number 1. Let's suppose we had the log of x plus the log of 5. Okay? Log of x plus the log of 5. All right, so I want to condense this. So it's in expanded form. I want to write as a single logarithm. So remember, when you're taking the sum of two logs, and keep in mind that whenever you're condensing, you better make sure that the bases are the same. Okay, so this was log x and this was log 5 base 6. You couldn't condense this. The logs have to have the same base. Keep in mind that when condensing, okay, the logs have to have the same base. Logs have to have the same base. Okay? All right, so keep that in mind. So when you go in like this, see how the bases are B, B? They're the same, right? They're the same. Okay? All right, so when you have the sum of two logs, what does that look like? That looks like a product, right? So that means that you're gonna say the log base b of the product of those two arguments. So what's the argument here? X. What's the argument here? 5. So you're going to say that's going to equal log base b in parentheses of 5 times x. All right, it kind of makes sense because if you expanded this, when you get this back. All right, so think about when you write as a single logarithm, if you expand it, if you would get this. All right. Okay, number 2. Suppose we had this. Log of x minus the log of 5. All right, so now we have a difference. So what does that look like? Which of these logarithms, which of these laws properties should I use? The difference, right? So I'm going to use the quotient. Now keep in mind that the argument of the first log is in the numerator. The argument of the second log is in the denominator. So that would be That would be, what do you think that would be? So when you think of difference, you think of quotient. Now here's a mistake people make, a very common error for this, a common error is this. They want to say log of x divided by the log of 5. That's not true. Okay? That's not what this is. So when you go back to the quotient rule, do you see a log in the numerator and a log in the denominator? No, you just see one log, right? So be careful. That is not this. This right here is this. It's the log, 1 log base b in parentheses x divided by 5. That's what this is. This is not that. That's a very common mistake people make. All right. So remember, as you condense, you're using your property going the other way. So you see how you have one log in parentheses, one log in parentheses? Okay, so keep that in mind. All right, number 2, suppose we had the natural log of x plus the natural log of 3. All right, no big deal. If you did number 1, you can do number 2. So what do you think that is? Okay, that's a product rule. So you're going to write this as the natural log of 3 times x. All right. What about, let's see, what about this? Number 3. What about if you had 2 times the log of x plus 4 base 2? 2 times the log of x plus 4 base 2. All right, so remember, see whenever you condense, you always want to make sure you have a coefficient of 1 in front of the log. I don't have that, I have a 2. But what does that look I'm going to use? If I look at these 3 right here, what does that look like? Is it a product rule, is it a quotient rule, or is it a power rule? It's a power rule, right? So I'm going to take this 2, I'm going to write it back as an exponent. Remember, that was an exponent. Write it back as an exponent. So it becomes the log base 2 of x plus 4 squared. And that's what that is. And if you expand and you take that exponent and pull out in front, don't you get that back? So always think about what you get back. All right, number 4. All right, suppose we had 1/3 times the natural log of x. 1/3 times the natural log of x. Okay, now the reason why I put that one in there was just to remind you about what it looks better as. So you all know that this needs to be a 1, all right? And so first thing you're going to do, which rightfully so, is you're going to say, well, I'm going to write this as an exponent, so I'm going to say the natural log of x to the 1/3, right? Okay, no big deal. But we prefer, remember when you go back to the previous lessons, where we wrote this as a radical, we prefer that you write your rational exponents, write the rational exponents as a radical. So remember, x to the 1/3 means the cube root of x. So that's what we prefer you write, okay? So that's the 1. Okay, number 5, let's suppose you had this. Log of 25 plus the log of 2. I'm sorry, log of 4. Log of 25 plus the log of 4. All right, let's think about that. Well, that's the sum of 2 logs, right? So I can write as a product. Okay, so I get the log of 25 times 4. But what is 25 times 4? Oh, that's 100, right? So log of 100. Now remember, think about the log of 100. This says, where possible, evaluate. Can I go any further with this? Yes, you can, because that base is 10. 10 to what power is 100? 2. So the answer is 2. All right, don't leave it like this when you can go further, okay? So if you go back to all the other examples, we couldn't go any further. Now you're at a point where, oh, I can go further with this. All right, so that was number 5. Okay, number 6. Okay, 6, suppose we had the log of 8x plus 5 minus the log of x. 8x plus 5 minus the log of x. Okay, no big deal. We had one a while ago like that. I know that the difference of 2 logs is a quotient, so I can write this as the log. Now, there are a couple ways you can do this. You could say in parentheses 8x plus 5 divided by x, just like that, and You saw that in a previous lesson. Now, if you want to, I could also write it like this. Log of 8x plus 5 divided by x. All right? So it doesn't matter which of these you use. Just keep that in mind. Okay, now let's look at this. Suppose we had all right, suppose we had the log of x plus 8 log of y. Log of x plus 8 log y. Okay? All right, so the first thing you got to do is keep in mind that in order to condense, I need to say this also, in order to condense, notice that these logs, both these logs, had a coefficient of 1. So one of the other things I need to remind you of is this. If you're going to condense, these coefficients right here have to be 1. These coefficients have to be 1. These coefficients have, the first two. Coefficients have to be 1. Okay? 1, 1, 1, 1. You're subtracting 1 times the log of n. All right, so those coefficients have to be 1. So the point being this. So in number 7, I cannot use the product rule first because that's an 8. What must this be? A 1. All right, so you cannot use the product rule first. So what should I do with this 8? What rule should I use now? The power rule. Okay, so you got to write it as a log of x plus the log of y to the 8. Now that these coefficients here are 1s, I can write as one logarithm. And so since that's a sum of 2 logs, I'm going to write as a product. So it'll be x times y to the 8th. Okay? All right, so that's a different one from the previous 6, because in the previous 6 we didn't have to discuss this because all the coefficients were 1s before. Now we have one where the coefficient is not 1. If you're going to condense, these coefficients have to be 1. All right, so keep in mind the coefficients have to be 1. Okay, and your answer, the coefficient has to be 1 as well. All right, number 8. Okay, so keep that in mind, and let's look at number 8. So suppose in number 8, I had this. 7 natural log of x minus 5 natural log of y. All right? Okay. So what do you think you can do first? First of all, I'm going to ask you, can I use the quotient rule first? No, why not? Because these coefficients are not 1. So what rule should I use first? The power rule. So let's use the power rule first. So this becomes natural log of x to what power? The 7th. Minus, and this becomes natural log of y to what power? The 5th. Now, can I use the quotient rule? Yep, yes you can. So that becomes the natural log of, in the numerator, it's x to the 7th, and the denominator, it's y to the 5th. Okay? All right, so that was that one. And notice that the coefficient here is 1. Number 9, let's suppose you had, okay, now let's suppose you had the natural log of x minus 1/4 times the natural log of y. Natural log of x times 1/4 minus 1/4 times the natural log of y. All right, so again, you got to make sure that this coefficient's 1, this coefficient's 1, so I've got to write this back as a power. So I get natural log of x minus the natural log of y to the 1/4. But remember, whenever you have a rational exponent, you need to rewrite this as a radical. So this becomes natural log of x minus the natural log of the 4th root of y, right? Okay, 4th root of y. And so I get the natural log of, well, okay, so then I can write this as a quotient. So this natural log of x divided by the 4th root of y. Okay, and that's it. That's all you do. Okay, number 10. Let me go ahead and do number 10 right here. Number 10. Now let's suppose I had this in number 10. All right, let's suppose I had 5 times the natural log of x plus 3 minus 2 natural log of x. So 5 times the natural log of x plus 3 minus 2 natural log of x. So you all know at some point I'm going to have to use a quotient rule and the power rule. Can I use a quotient rule first? No. Why not? Because this coefficient is not 1 and this coefficient is not 1. They must both be 1. So we got to use the power rule first. So this becomes the natural log of x plus 3 to the 5th minus the natural log of x squared. And now I can use the quotient rule. So this becomes natural log, in parentheses, the numerator is going to be this, x plus 3 to the 5th, and the denominator is going to be x squared, just like that. Now if you want to, you can rewrite it a little bit better, where you can just say x plus 3 to the 5th divided by x squared. Okay, as long as it's obvious that you're taking the natural log of this fraction. All right, so that's number 10. Okay, number 11. All right, suppose in number 11, I have this. Number 11. All right, number 11, let's suppose I have 3 natural log of x plus 4 natural log of y minus 7 natural log of z. All right, now this time I have 3. We can handle that. In the previous 10 problems, there were only 2 logs to deal with to condense. Now we have 3 that we have to condense. Okay, just like before, the first thing you got to make sure is that all these logs have a coefficient of 1. All right, either 1 or negative 1. So this is going to become the natural log of x cubed plus the natural log of y to the 4th minus the natural log of z to the 7th, right? Okay. Now, just like you would in any order of operations, we're going to go from left to right. You're going to add and subtract from left to right. So let's do this first. From left to right. Remember, order of operations. Add and subtract from left to right. So I'm going to use the product rule with these two first. So that becomes the natural log of x cubed, y to the 4th, minus the natural log of z to the 7th, right? Okay. And now I'm going to use a quotient rule. So that's going to be the natural log. In the numerator, I'm going to have x cubed, y to the 4th, and the denominator, I'm going to have z to the 7th. And there's your answer. Okay, so that is this. Kind of makes sense because in part 2, when you had to expand, then we used the quotient rule first. So we said the log of the numerator minus the log of the denominator. And then we used the power rule. You see how it goes backwards, just like we did in part 2 when we expanded. Okay, so when we expand and condense, see the difference? Very similar. All right, number 12. Okay, so let's make this a little bit simple at first. So suppose I had this. Suppose I had 2 times the natural log of x plus the natural log of y. Okay, 2 times the natural log of x plus 2 times the natural log of y. Now what some people are going to have the inclination to do is they're going to want to distribute. All right, if you do that, notice what happens. If you distribute, you get 2 natural log of x plus 2 natural log of y, right? But that doesn't help you to condense, because when you condense, what must you have here? You got to have 1. So leave it like this. Don't distribute. Cover this up and notice, oh, okay, so these have in the bracket, this has a coefficient of 1, this has a coefficient of 1, so I can condense this. So when you condense this, it becomes the natural log of xy, right? But what are you multiplying that by? You're multiplying that by 2. Now, remember, your final answer, you still must have a coefficient of 1. So now you're going to use the power rule. So this becomes the natural log of xy squared. Okay? All right, so there's your answer there. And then go backwards. Think about this in your mind going backwards. So using the power rule, this is 2xy, just like this, and then expanding it, you get that. Okay? All right, number 13. All right, so in 13, let's suppose we had this then. Let's suppose we had 1/2 times, in bracket, the log of x base 4 plus the log of y base 4. Let's suppose we had that. All right, well, just like that, I wouldn't distribute first, because if you do, you're back into that situation. So I would cover this coefficient up, and then notice that I can use the product rule here, and so that becomes that becomes 1/2 times the log base 4 of xy, right? And then I can rewrite this as an exponent, so that becomes the log base 4 of xy to the 1/2 power. But again, don't leave it as a rational exponent. You must write it back as a radical. You must write as a radical. Okay, so keep that in mind. That becomes the log base 4. Remember, 1/2 exponent 1/2 is the square root. This is the square root of xy. And that is it. That's number 13. Okay, number 14. All right, number 14. Suppose we had, all right, 14. Suppose we had this. 1/3 times the, in parentheses, the log of x base 3 minus the log of y base 3. All right? So it's very similar to number 13 in it, except instead of a sum of two logs, this is the difference of two logs. So I'm going to use the quotient rule first. So again, don't distribute. It's not going to help you. All right, so when I use the quotient rule, this right here becomes the log base 3 of x divided by y, right? Okay. Now I'm going to rewrite. Remember, that's not your answer because you want this to be a 1. So I'm going to rewrite this using the power rule. This becomes an exponent of all of this, okay? So this becomes 1, the log base 3 of x divided by y. Notice I'm putting parentheses because all of this is raised to 1/3 power. And then all I got to do now is change this to radical, so that becomes the log of the cube root of x divided by y. Okay, and there's your answer. Base 3. Forgot the base. Base 3. Okay. 15. All right, 15. Let's suppose you had this. I had the log of x minus 2 log of y plus 3 log of z. Okay? Now, remember in number 11 we had 3 logs? Same idea, except notice that the order of operations was I added first and then subtracted. Here I'm subtracting and then doing what? Adding. Okay? But remember, the first thing you have to do is make sure that these coefficients are 1s. So let's go ahead and use the power rule first. You must use the power rule first. Okay, so keep that in mind. And the reason why you must use the power rule first is because you need the coefficients to be 1. All right? So I have the log of x minus the log of y squared plus the log of z cubed. Okay? So let's use, so remember order of operations from left to right. So we're going to do subtraction first. So that becomes the log of a quotient. So that's the log of x divided by y squared, right? Plus the log of z cubed. And now I'm going to write this as a product. So that becomes the log. Remember, you need one fraction now. All right, so I got to remind you something. You see, we're multiplying the arguments, right? So I'm asking you this. What's x divided by y squared times z cubed divided by 1? Because z cubed is the same thing as this. So if I write it as 1, do y'all agree that's x times z cubed? Okay, divided by y squared times 1 is y squared. And there's your answer. All right. Kind of makes sense because if you were to expand, if you were to expand, let's see. So let me make sure I did this right. So x divided by, then plus, so it'll be the product, log of this times this. Yeah. All right. So if I were to expand, notice that, okay, I want to show you that this is correct. All right, because if you think in your mind, you're probably thinking, well, that doesn't look like what I would get if I expand. It is. Watch. Let me show you. So y'all agree, so let's check this. All right, so you get the log of xz cubed minus the log of y squared. Y'all agree? Okay. Now if I expand this, that becomes the log of x plus the log of z cubed minus the log of y squared. All right. Now if I go ahead and use the power rule, I get the log of x plus the log of, plus 3 times the log of z minus 2 log of y, right? That's what I would get. So you're probably asking, you're probably saying, well, that is not this. Yeah, it is, because remember, the order in which you add things does not matter. So do y'all agree? Do y'all agree? Can you agree that this is the same thing as this? So I can put the log, I can put this term first and then this, right? So log of x minus 2 log y, and then plus 3 log z. All right. So the order in which you arrange terms does not matter. So for example, note, if I have 3 plus 7 minus 2, okay? Do y'all agree I would get the same answer if I did this, 3 minus 2 plus 7? Yeah, all right, the same thing. So that's what's happening. So this is still correct, because if I expand it and then rewrite some terms, I get this back. All right, so that was 15. So that was a good problem to expand, just to check and see if what you would end up with is the same thing as this. All right, then number 16, let's look at 16. All right, 16. All right, let's suppose we had, all right, let's try this one. The natural log of x minus, now this one's a little bit more difficult, 4 times the natural log of x plus 2 plus the natural log of x minus 2. All right, so it looks a little bit more difficult, but don't make it be too difficult. Just think about your properties. All right, so first of all, you do understand that you can't use the quotient rule first because of this 4, right? So I got to rewrite this. I got to rewrite this as an exponent. But even before I do that, what can I do with what's inside here? Yeah, so I can write what's inside as a product. All right, so let's do that first. So let's look at this first. So it becomes the natural log of x minus 4 times the natural log of x plus 2 times x minus 2. Y'all agree? Okay. And if you wanted to, you don't have to. If you wanted to, you can multiply this out. Does not matter. Because remember x plus 2, x minus 2 is x squared minus 4. All right, so if you want to, you could do that. Does not matter. Okay, now you're going to rewrite this 4 as an exponent. So that becomes the natural log of x minus natural log of x plus 2, x minus 2, all raised to the 4th power, just like that. Okay, so all of this is so this product is being raised to the 4th. And now I'm going to write a quotient. One more step and you're done. So it becomes the natural log of x divided by x plus 2, x minus 2. All of that is being raised to the 4th power. Okay? Now, if you wanted to make it x squared minus 4, this is what I would do. I would, at this point right here, at this point, I would say natural log of x minus the natural log of x squared minus 4 to the 4th power. See, this is x squared minus 4, right? And then that would be the natural log of x divided by x squared minus 4 to the 4th. So either one of those is fine. They're the same thing. These two right here are the same thing. Okay? All right, now, let's see if you remember something we said earlier. Okay, what if we had this? The log base 2 of x plus the log base 5 of x plus the log base 2 of y. Okay? Now, I want to condense this as much as possible. Okay? Condense as much as possible. All right, now, there's no way I can condense this to one logarithm. why can't I condense this to one logarithm? Because all the bases are not the same. This base is a 2, this is a 5, this is a 2. In order to use those properties, the bases have to be the same. But what do you notice about the first and the last? Well, those are alike. So I'm gonna rewrite this to make it look like this. Log base 2 of x plus the log base 2 of y plus the log base 5 of x. Okay? And now I condense these two. So it becomes the product. So it'll be the log base 2 of xy plus the log base 5 of x. And that's all you can do. There's no way you can write number 17 as one logarithm. So that's all you can do. You can't do it because the bases are different. And that's all you can do. All right, so that was number 17. Okay, so that will take care. I think you have enough problems here to understand the idea of condensing condensing log expressions. So remember, when you condense log expressions, you have to make sure that the final answer, the coefficient of the log is 1, right? And then the other thing we saw was that before you can condense, before you can use the quotient rule or the product rule, that these coefficients have to be 1. So you have to do the power rule first. All right, so go back over this lesson if you need to, but that should take care of part 3.